All right. Hi. Um, so this is like we're trying a new format for this tutorial because last week it was not amazing. So what we're gonna do this week is I am going to go over everything that I was supposed to go over last week. Um, and basically finish off that tutorial. This way, you guys will have a video of it, a full video with no interruptions, no questions, no anything. Um, and I'll essentially be posting it on a discussion board. In that discussion board, I will ask that you post a timestamp for where you had a question, and then ask your question. And I will do my best to answer them during our tutorial slot on Wednesday. This way, we can get through everything in a timely manner. You guys can have some time to mess around with the video and make sure that you're finished it before our tutorial. Keep in mind, like it will be expected that you finish it before the tutorial. This is essentially, I guess, homework. I don't like giving homework. But yeah, I'm looking forward to it. So what we're going to start off with is this. So the biggest thing that I want to go over is I know the issue was I had to rush through everything, and people like things happen. People got lost. People got stuck behind. It happens with everything. That's a very, very, very normal sequence of events. Also, I should apologize in advance if my dog barks. And for the washing machine, my family has all decided to do their laundry right now, all of a sudden. So that's fun. And there's not really any other time that I can record this, sadly. I need to record it now, or else I don't have enough time. So basically, what happens is so we talked about this during the tutorial. This is our constructor. And all we're doing here is this is a new scene. So if we go over here, right in, this is what there was. This was here originally. So if we run it, we're going to get a default scene. And all that happens in this default scene is hello world just flashes. That's it. That's all. Very simple. Keep in mind, the scene itself has all of these. All of this. So, all that you guys need to do is understand. Oh, and we will be making some changes to the code. I should clarify that. We will be making changes to the code during this tutorial. So if you don't have your file open currently, even if you completed what we did last tutorial, I would recommend you open it up now and be ready to change things. I'll give you a few seconds to do that. Or you can pause. Preferably pause. But yeah, so make sure everything's open because we also need to write this. We also need to write an unload function for our new scene. Obviously, our unload function is just going to call this unload function, but it's still an unload function that we need to have. So you'll notice, like, obviously we had our default scene. And then when we write in first creation file, we're going to get what we made in class, which for me is just the link sprite. That's all. It's very simple. Very simple. We can actually, like, if we really wanted to, we could implement the set transparency. We could make it go transparent and untransparent. That may be something that I do at the end of the video. You don't have to watch it. It's just an idea. But basically, all this is a scene. You'll notice if I put any other type in. So you see this back end, how it's the same color. Also, I noticed a few of you guys asking for the specific my color scheme. I'll post that somewhere in the Discord. I have posted it somewhere in the Discord. I actually took it from one of my TAs back like 2 years ago. Yeah, but I'll make sure to post it somewhere so that you guys can have colors, because I completely agree. There is too much white in the default color scheme. I love this color scheme. It makes it so easy, because statics are a different color, static variables. Things are basically, it makes it easier to tell everything apart when everything's not white. I'm not going to explain more than that. I don't, because if I do, you'll notice that these are bold. There's a reason why they're bold. These are bold, whereas this is regular. But you'll notice we can't use backend as a scene. And the reason for that is because backend isn't a scene. What this requires is that it implement the basic. Oh, there we go. That it implement this. So I can't explain all of this. The issue is this isn't a programming class. This isn't the class where you guys should be learning this. But I will be giving you guys the gist. Basically, all you need to know to be able to use it, to be able to actually program in it. The issue is if I spent the time to teach it all, the tutorials would just turn into that. And that's not good at all. That's not something we want. So, what we're going to do here is, so this is inheritance. Inheritance basically means, hey, so you see this new, so like imagine you have, I'll draw it. Hopefully that should make it easier. I'll draw it while I explain it. Hopefully that should make it easier for people to understand. Basically, so let's say you have a parent. This is a parent. Excuse my horrible handwriting, but this is a parent. So this parent, when that parent has a kid, has a child, that child inherits different genes and stuff. So in programming, it works the same way. So we have scene. Scene is the parent of first creation, which basically means, so if we go back to where scene was, if we go in here, you'll notice that scene has all these virtual functions, and we talked about this in class. I briefly went over it. You'll notice they're all virtual. So what that means, so this is a pure virtual. Well, this isn't actually a pure virtual. This is an empty virtual. I didn't make any of these pure virtuals. The reason why is because you can't, the way that we used scene here, if I made any of these pure virtuals, which are a thing you will learn about, can't explain. I don't want to overwhelm you, because if I overwhelm you, programming can be very scary if you hear all these terms and don't know what they mean. And I assure you, it is not a scary thing. These are very simple terms, and they will make sense in time as long as you keep learning, you keep trying, you keep practicing. But basically, all this means is I am taking these, all of these all exist within this. Every line that's in here exists in this. You'll notice this is where our gravity is written, and we use gravity here. We never declared this variable. We didn't. That variable isn't here. It doesn't exist here. But we're using it, and there's no issues. The reason why is because it exists here. It's because it exists right here. But yeah. So that's inheritance. This should hopefully get the gist across. I can't give you guys like the full background information, because that's like when we learned it in class, that was 2 full lectures worth of content. That was 2 3-hour lectures, which it's a lot of time. Keep in mind this tutorial is only an hour and a half long, even though I don't know how long this video is going to be. But basically, this is the gist. So, scene is the parent, first creation is the child. All we've done is inherit traits from scene, so values from scene. We've inherited this, we've inherited this, we've inherited this, we've inherited this, and we've inherited all of these. All of these functions are all functions that I can do in this. These are all functions that I can do that are completely valid. All of these. All of these are completely valid. And so what we're doing here with the rest of the functions that we're writing, you'll notice this keyword override. That's what those are referred to as. Keywords. The blue words that come after, those are keywords. And basically, what that means is this is overriding. Sorry, I should just open it. This is overriding this function. So our void update override. Our void update override basically, sorry, I lost my train of thought for a second. But our void update override essentially takes this, which currently has stuff in it, takes this and overrides it. This is no longer what update does. Now, if I didn't have this override, update wouldn't be doing this stuff. Now, if I didn't have this override, obviously it just wouldn't do the thing. And essentially, that's why we override all of these functions. This is a brand new function, though. This function right here, this is a member or a method. You'll learn about that in second semester. You'll learn why we call them methods. The simple version is, this is a class. Any function that is outside of a class is a function. Any function that is inside of a class is a method. That's all. It's pretty simple. But so you'll notice we also don't have to take all of these. We don't have to overload all of these. Currently, gamepad stroke will just do nothing. Gamepad up will just do nothing. Gamepad down will just do nothing. Gamepad stick will just do nothing. And so on and so on. However, we implemented the keyboard stuff and overrid them. Now they're down here. They are empty currently because we never got to filling them. But they exist. They exist as part of first creation and have been overridden as part of this. There are specific reasons why we use virtual functions and why these functions exist in a base. But I will get into those at a later date, specifically. But hopefully that should clear up why we're doing things this way. I know I didn't get to explain a lot of it when we first rushed through it, and I do apologize for that. Hopefully this version of teaching will help people better. This way everyone can watch the videos over, pause if they're stuck, replay a part over and over again until they understand it, or they can leave a comment on the discussion board and ask for help with a timestamp, and which I will be mentioning in the discussion board where I post this, that if you ask for help, you should be posting a timestamp. And if you don't put a timestamp, I will be asking for a timestamp. You won't get a full response. You'll get where did this happen. This is so that other people, if they have the same issue as you, they can check at the exact same timestamp. If their question is at 2:42 and your question's at 2:45, obviously their question might answer your question. But yeah, so basically, that is the gist of the header file. So header files are where we write our declarations, essentially. This is where we write this stuff. This is where we write our class declarations. Source files .cpps are where we write our definitions. And so just remember, in any scene that you create, you need this line. If you want everything to properly create itself, you very much need that line. If you don't have that line, your physics won't work, like at all. Like at all. Because this is where you actually create the physics world. So make sure to have this line. Essentially what we do here is all we're doing is taking the gravity, setting it. It's hopefully very simple. If there are any issues with it, please ask in the replies. But essentially what we're doing here is we are writing everything that needs to be like written to make sure that this is a top-down scene. You'll notice I have a comment here. These are important. Don't over-comment your code, but like try to put things like, this is a top-down scene. Like, this is over-commenting. Obviously, I shouldn't need to mention this. I should instead do something like top-down scene, like a description of this scene somewhere, basically. And then from that information, everyone should be able to understand all of my code. Basically, what we're going to do here is we're going to change a few things. So first thing we want to do is make sure that this isn't, if this is not equal to, this is the first change that we need to make. Null pointer. So this is a pointer. I am not explaining pointers because if I explain pointers, all I will do is confuse you. Pointers are the bane of every programmer's existence. They are also the thing that makes making games possible. Just know that we don't want it to be a null pointer. So if it's a null pointer, what we do is create a new registry. It's the exact same as what we have in here. So we check this. There's also this. We do need to create that. That is one thing that I didn't get to do last week because I didn't feel it was as important. But essentially, these are super important. So you just want to unload. You don't want to override it though. So specifically, the reason why we're not overriding this one is because we're trying to create a new definition. And then what we're gonna do here is essentially call the old one scene unload. That's all we have to do. We just created a new unload function, and all it does is call the old unload function. You'll notice this one isn't virtual, and the reason for that is because you should always have a base unload function that'll unload any of like the basic things. You'll notice I create the physics world in here, thus the physics world should be deleted in here. Technically the scene registry, it is a, if you'll look down here, it is a part of this place. It is a piece of this class, so it should be cleaned up in this class. This way you don't lose track of things, this way you don't confuse things, this way you don't, like, you know, just mess things up. You don't want that. That's not something you want. But essentially, what we're gonna do is, now that we've done that, everything's being cleaned up after automatically for us, and we don't actually need scene to be open anymore. Actually, so we can close it. But so basically, from here, what we need to do is attach our register. And All this allows us to do is use these, because otherwise we have to do, I don't know, so what I've written here, these are like wrapper functions. So all this create entity does is mreg.create, mreg.destroy. You know, it just does simple stuff. It just get component, remove component, set up identifier, ignore that function. But so what I have to do if I didn't have this is this is what the code looks like if you don't attach it. So dot get camera entity. It's shorter, yes, technically it is shorter, but it doesn't look as clean. It is because you have to like make sure to put this. You have to make sure that you don't screw up anything. You have to make sure that you're doing this right. And if you change anything, it'll also be weird. This just is a very simple way of writing it. This just keeps everything put together for everyone, all nice and neat. And so this is the way I prefer to do it. If you want to do it the other way, by all means, go ahead, do it. But the biggest thing that you need to take away from this file, there is one big thing that you need to take away from this file. That is, so these blocks of code, I have them sectioned off. I have them sectioned off using these. So what this means is that this value, so if I write, so this is a variable that we've created. So technically it should exist out here. If I write entity, does not exist. These braces are local space, basically. So anything created in here, so entity and temp, those both only exist in these braces at all. They don't exist anywhere else, unless you recreate them. If I could now do int entity equals 1. Now what that does, see, it exists, but it's angry at me because IntelliSense doesn't want to color it right. You'll notice that a lot. Sometimes IntelliSense does that. It's okay. But basically, what you want to take away from this is that this brace to brace right here is how to make a camera. And so this camera, what we're doing here is we're creating a camera, or we're creating an entity. We are attaching a camera. We are attaching a horizontal scroll and a vertical scroll. Then we are assigning the size. This is the size of the camera. We're setting the size. And then we're storing how big the window is, because that matters to the camera. And then what we're doing is we're creating a matrix for the camera. That's all that this does. This just makes it so that you can... it just flattens the world into 2D. And then what we're doing here is we're storing our camera component. See, we're storing the component inside of our horizontal scroll and our vertical scroll. And our horizontal scroll and our vertical scrolls need this so that they can check if the focus, like the player, moves outside of a certain range, it'll move the camera over, which is very important. And that's literally all this does. This creates a camera. You cannot render a scene. Your scene will not render if you do not have a camera. Nothing like your game. If you do not, like if I were to comment this out right now, if I were to comment this out and run first creation, it will crash. It will fail to run. The moment I run it, I'm going to get an exception. And that exception is going to be, it's basically going to be an entity error. it's going to be mad that it can't find the entity, basically. Computers get mad when they can't find things like that. See? This was null pointer. See? The entity didn't exist. And so, what I'm going to show you guys with this is whenever you get an entity error because this entity was not found, if available was false. So if available was false, which this is false, what we do is we go up here and we find the first thing that we recognize. So the first thing that we recognize is init scene. You'll notice this was an issue. Couldn't create the entity. Anyways, yes. I actually believe that might be a different issue. But this is good, because this way I can show you guys that issues happen. Yeah, I was right. This is a different issue. So, very different issue. Oh, I wrote not equals. You want that to be equals. If it's equal to null pointer. Oops. So what that means, that error means that the scene registry doesn't exist. If it doesn't exist, you can't create an entity. So that's a thing. Oops. That's on me. So if we comment this out, now we're going to get a different error. It's probably going to make a, no, never mind. It just did this. So this specific error, you're going to see this error a lot. You're going to see this error a lot. And basically, what this error means is it couldn't find your entity. Learn to recognize this error. You got to learn to recognize basically different errors. So what this means is if we scroll down here, go to horizontal scroll get. So we recognize horizontal scroll this. This isn't what we want to go. Keep going down. We recognize ECS get component. This clearly isn't where the error is. So the last possible one, init scene. So the issue here is this is trying to get the main camera. Oh, would you look at that? There is no main camera. Man, that's weird. We should make a main camera. This entity does not exist. That's weird. Man, I wonder what would happen if we were to rerun now after uncommenting. I wonder what would happen. Because now we have a main camera. And it runs. It runs without any issues. Runs just fine now. I like making it small. But it runs just fine now. And that's good. That's a very good thing. So basically, everything runs just fine now. The issue with this is every single scene that you create will need a camera. You can't render anything without a camera. Imagine the camera as the eye, and if you don't have an eye, then you're not going to see anything. There's going to be nothing there. And basically, it's you need an eye. I can't really give much more of a reason than that. You need an eye. You need something to see the world that you are creating. And if you don't have a camera, all you're going to see is black. And you'll learn that in Unity when your game design teacher goes over it. You guys will learn that in Unity, where in Unity, if you delete all the cameras, nothing renders. Or if you do things a specific way and don't have any cameras set as the main camera, Unity gets mad at you and only renders black. It just renders a black screen. That's it. Okay, so now that we know what makes the camera, so all you have to do, all you have to do ever when you create a new scene, you can actually, if you really want to, just copy. Because you'll notice that if I go into scene, you can just copy paste this code. It's basically identical. The only difference is this one doesn't scroll. This one doesn't scroll at all because there's no player in it. But this one scrolls because we're going to have a player. And lo and behold, the code right below it. This is what creates a sprite. Now, this code will not always be identical. Sometimes you want a sprite to have a physics body. Sometimes you want a sprite to have... no, physics body is pretty much... Sometimes you want it to have a player controller, which you can make custom. Sometimes you want it to have like AI behaviors. Sometimes you want it to have like a health component. Sometimes you want to attach your UI component to your player so it'll follow your player. Any of those things. Keep in mind you need to create your own UI. That's all on you guys. It's just a combination of different sprites, basically. And I highly recommend going to GPC to check that out. Now we are just passing the 30-minute mark. And I'm trying to keep this under an hour. I don't want you guys to have to watch like an hour of videos every week, and then come to class. Keep in mind I will be shortening the tutorials for this, because I also have office hours, but it'll also be expected that you watch these before the tutorial. This way I don't want to expect you guys to be up so early or be there for so long. If I'm already making you guys watch an hour of videos. That doesn't seem very fair. But basically, so this code right here creates an entity. Now, there are a bunch of other things that we can do. We have this is something we'll go over later. Physics bodies. So you can attach a physics body. Don't do that now. Because there's a whole bunch of other stuff you need to add to make a physics body work. Because all that does is attach an empty container for a physics body. You can also attach... I don't think we have anything else. Yeah, no, we don't have anything else. Currently, there's nothing else that you can attach. That is other stuff. Yeah, no, there is nothing else that you can attach. I am looking at the sidebar now. Yeah, there's nothing else. You can write your own custom ones, though. That's the whole point of these. So the whole point of components is this is just a regular class. This is just a class. This is just a class. You can write your own. This is just a class. You can write your own. So you can create all of your own stuff. The only limit is, you know, your coding ability and how willing you are to ask for help. Because there you guys have the entirety of second years that all used this framework, that wrote amazing games. Like, mind-blowing. In no world did I ever expect that the quality of the games that they made using this framework at all. And I highly recommend taking advantage of that fact. Go to GPC. Go to the other like Discords. Go to everything. Make sure you take advantage of these opportunities that you've been given, because those second years didn't have that. The only person that they could come to for help with the framework was me, and I had my own classes. I couldn't help them all the time. They learned through suffering, and you don't have to do that. Not anymore. You have them. Make sure to take advantage of that. But back on topic. Basically, this creates a sprite. All it does is, so what we're doing here, I'll walk you through the code. So we create our entity. We make sure that we clarify that the main player, this is the main player. So if you look down here, we have this thing called main entities. And this just stores what our main player, like, so entity is just an int, if you look closely. It's just an int. That's all. Just an int. And this is just an int. So all it does is store the int. And this way, when we want to access our main player, if we want to access the transform on our main player, like right here, all we do is put main entities, main player. That's it. That's all. You can also just store, like you can also just private int main player. and then you can write it here. And you'll want to do this for some items, actually. You will want to do this for some items, but we have the main player so that you can always control the main player from any function in the entire in the entire program. You should almost always be able to control main entity player. Next up, we add the components. We add Sprite. We add a transform. So Sprite is what stores our texture and stuff. Sprite is what makes it like render as something. Our transform is just the position where we place it. If we want to move it, we use the transform. If we add physics bodies later, you will see later that when we add physics bodies, we use the physics body to move it rather than the transform. But essentially, like, we need both. In order to make a sprite, you need both of these. This is all you need to make a sprite. This is everything that you need. What we do here is we store, we create a file name. We're loading in link standby. I can grab any image off the internet if I really want. And it'll do the job. And then we load in the sprite. This is actually, I didn't get to go over this in class, but this right here, this is the width and height. So we have it at 100, so I can make it 150 by 60. And now it's a really wide sprite. You'll see in a sec once it finishes loading. Now it's a lot wider. See? And then if I make it like 300, it's going to be a little ridiculous. Just a little bit. Just a tiny bit. See? This is just the size. So I like it at 100. Actually, I honestly prefer it at like 80. Because this is a 4:3, I believe. Yeah, see? See, that aspect ratio makes sense. So this sprite doesn't look stretched, doesn't look stretched in any axis, which is a good thing. This is what we want. So you need to always keep in mind the ratio that your original sprite had. So let's say your original sprite is 200 by 400. Like, here, I'll draw it. That actually makes it a little easier. Writing it doesn't really get the point across. Then we just delete. And then we just do backspace. Alt backspace? Backspace. Backspace. There we go. So now, so let's imagine that your original is this, like by this. So it's 400 by, wait. Sorry, I always forget that it's the other way around. Don't know why I always forget that. But, so your thing is 400 in the X. Your image that you've made, your sprite. 400 in the X. By 200 in the Y. Like, let's just imagine that there's a whole bunch of like transparent pixels around this guy. Why do I do this? Why am I like this? I meant 200 by 400. So it's 200 pixels wide, 400 pixels high. Because as a person, typically you want like more height than width. Sometimes you might want more width than height, but for a person, for like a player, a lot of players, like humanoid players, are typically higher than they are wider. So like just pretend that there's a whole bunch of transparent pixels here. So you got 200 by 400. So what can we divide that down to? So this is 2 by 4. Or we could divide that even further. So it's a 1 by 2, which is 1 to 2. So for every 1 width pixel, we have 2 height pixels. So how does that work in this? Well, for example, so what this is a, I cannot remember for the life of me what the math is here. But imagine if link was 1 by 2, just like this example that we have here. And we wanted to make him way bigger, obviously. So we would multiply this by 80. So if we wanted him to be 80 wide by default, we would make him, what would we would multiply this 80 by 2. So we would get 80 by 160. And so the thing we would enter is 80 and 160. That's it. That's all. It's pretty simple. So it's very simple stuff. It's just basically keep the aspect ratio. Make sure to keep your aspect ratios. Because if you don't, for example, our link sprite does not, I repeat, does not have an aspect ratio of 1 to 2. Do you want to know how I know that? Well, if I do this and run it, it's not going to be pretty. Link is very stretched. It does not have a 1 to 2 aspect ratio. Basically, depending on how big you want your sprite, just make sure to keep the aspect ratio. Don't change it too much. You can change it and make it do animations, like make it, you can force it to compress if it gets hit, make it look like it got bounced on. That's a clever thing that you could do. But don't change it. It'll just look not good if you don't respect the aspect ratio. All we're doing here in this next line is setting the transparency to 50%. I can set this to any other number, 90%, and all it's gonna do is make him more opaque. Now he's not as see-through, which I am okay with because his colors look a lot better when they're not see-through. And then this just sets his position. I can actually change this to like -10, or here, we'll use a bigger number, -30, so it's noticeable. You'll notice he's a bit further down than he was. We can go even further and do -150. And you'll definitely notice that he's further down than he was. I don't think he's moving down. I'm pretty sure I'm setting his position again somewhere. Wait, no, he is. Wait, yeah, he is. He should be. Weird. Either way, point is, you can change these values and change where he is. Now, from here, this is where we stopped for the tutorial. This is where we stopped. Now, there was still a little bit more. What we want to do is, adjust scroll offset. So basically, if you change the size of the window, your scroll is going to offset. And you don't want that. That's not a thing that you want. And so this is going to go in the scenes file later. But I wanted to show this as part of the first tutorial to make sure that you guys know that the math going into it, because there's a lot of math. So what we got here is this is the max size of the screen, basically. So what we're doing here is we're grabbing that max size, camera, main entity. So what we're doing is we're grabbing the camera, so the main camera, .get ortho size. This is that ortho size that we set. So in this case, this will be about 75. Yeah, 75, and then the other one will be negative, or will be 75 as well, because we made our screen a square. Max size y equals get component, camera, main entities, main camera, get ortho size dot w. So the next thing that we need to do is get our player's half size. This is important to the math that we have to do, for the reason that there is an offset that is based on the size of the player, and it's a combination of the size using the aspect ratio, subtract the player size, and it'll adjust the scroll offset so that it doesn't get moved away. So your scroll bar doesn't get moved away from the player. And this is important because obviously the player should be centered, or at least within a reasonable distance of the center. It shouldn't be moved off of, you know, if you have an offset, it shouldn't be moved at like much at all. That's why we do this. So what I'm doing here is I am getting the sprite main entities. I'm getting the main player entity. And then I'm getting the width of the sprite and dividing it by 2, which is half player size. So, and then from here, we get the horizontal scroll. Main camera. Set offset. Oh, I forgot to get the main camera. Dot set offset. And then it's max size x times back, and we're getting the aspect ratio minus player half size. Uh-oh, we have an error. What went wrong? I'll tell you what went wrong. We don't have access to backend in here. So what we need to do is do hashtag include utilities. And now the utilities file includes backend. That's all. Pretty simple. Utilities file is also pretty useful. We're going to need that at some point later. Not during this tutorial, but we will need it for another tutorial. But you'll notice backend no longer has no issues. Now no longer has any issues, sorry. Next up, we have to get component, vertical scroll. And this one's a bit different. We do not need to multiply the aspect ratio in, because when it comes to camera math, you do not include aspect ratio in the vertical. You just adjust the horizontal. And all this does is make it so everything works properly and does everything right. I don't know why it's not coloring this properly, but that is just a quirk of, you know, of thingy for some reason. Apparently VS just doesn't like it. It happens. So, last but not least, this is the last part of the tutorial, and then we're done with this video, and then I'll be posting it up and making sure that everybody has access to it. So what we're going to do is we're going to grab our player. We're going to grab our player's transform. So ECS, get component, transform, main entities, main player, and then we want to make a speed variable, because we need to have speed. I'll show you some real speed. You know, that kind of cringy meme. I'm sorry, I'm laughing at my own joke. Kind of sad. But so what we're doing here is we have this thing called input. And so basically all this does, this grabs the input from our W key. And this basically just checks this will be true. So this if statement will be true as long as the W key is being held down. Hence why we're writing this in keyboard hold. Now, if we wanted to just have it so you could only press W to move, you'd have to press it over and over and over and over and over again. Then we would put if input get key up, key W. And that's all that does. And then there's also this does the exact same thing, just only triggers. So get key up triggers happens the frame that you let go of the key. Whereas get key, there's also input get key down, key W. And so this triggers. So if we printf key down, I will show you this when we write, when we get the movement in and we run it. So key up. So this will all print, do a /n. That's just a new line. That makes it so that it prints out a new line. But basically, we want to write WASD controls because WASD is superior to anything else. And obviously we're going to use it. So key S. And then get key A, and then get key D. Now we have WASD controls. So all we have to do is use this player that we got here and do player dot set position Y, player dot get position. So what this is doing is I don't know if you guys know the velocity equation. So the velocity equation, Dr. Hogue should have gone over it by now, but the velocity equation is velocity equals position plus speed. You know, velocity also has a direction, obviously, so it's a vector. But sorry, the speed equation is what I'm specifically trying to. No, that's right, I believe. It's position plus basically position, like change in position over time, basically, which is just speed. Change in position over time is just speed. Oh, if we want to do yeah, this is actually speed, but or not speed. This is updated position. I'm sorry, I didn't mean to. This is position 2. So we take position 1, we add speed, we get position 2. Now if we want to do it in like velocity stuff, it's displacement 2 is equal to displacement 1 plus displacement over time, because velocity and displacement both have directions, and in order to get velocity you need to have a direction, but in order to get speed you don't need a direction. This is math stuff. That's base math stuff that you'll learn through Dr. Hogue's modules and his iSolve module and stuff like that. You will learn that in class. This is just a practical usage of those things. So what we're doing here is we're getting the current position, and we're adding our speed variable times delta time. So delta time is less than 1. So this is the same as dividing by a specific number. So writing times delta time is the same as dividing by another number. Now, you don't always want to be using delta time. You should typically have a fixed delta time for physics, as regular delta time can cause issues. If you ever lag your game and go flying, that'll be because you're not using a fixed delta time. But for this example, we don't care. So this is the exact same thing. Get position Y minus speed times timer delta time. That's it. And then last but not least, player.setPosition x, player.getPosition x, minus, because this is left. So this is the reason why this is minus is because this is down, this is left, this is up, and this is right. So when you're going left in the x, that's negative. So speed times timer delta time. And that's it. Player.setPosition x, player.getPosition x. That's it. That's all. That's everything. So, oh, sorry. This should be plus. Plus. Instead of a subtraction. So you'll see these. I'm going to drag and drop over the console window this time. And you'll notice that we will be able to see it. I'll bring everything over here. We got this. We've got this. So whenever I key down, key up, key down, key up, key down, key up. You can also move around. You'll notice I can't go past a certain point on the wall. The actual reason for that is because the camera's actually moving there. Like our camera is actually like it's sliding around. If I were to stop this and like I don't have anything to see the camera right now. Yeah, I don't have anything to see the camera right now. But if I did, I would basically show you that it's you know, I actually can. So here, I will create. So using what we've learned today, using what we've learned in this tutorial, I would like for you guys to, after you finish watching this video, go into your thing and set up a new entity. Set up a new sprite. So creates entity, and I'm not walking you guys through this. I'm actually writing this to show you guys another thing. But basically, create entity. ECS set is. We don't actually want this to be main player. We don't want to control this. Keep in mind, the only player that you will control is the last one that you set as main player. So if you're setting multiple as main player, you're only going to control one of them. It does not allow you to control more than one. So ECS, attach components, sprite, entity, ECS, attach component, transform, entity. Now it has a transform and a sprite. So now we can take this, so file name, and what I'm gonna do is I want hello world back. So I already have hello world.png in the files. I just wanted to make sure that I was grabbing the right file name equals hello world.png. Oh, I forgot to add a semicolon. So ECS get component sprite entity.load sprite file name 80 it was 100 by 60 ECS get component sprite entity dot set transparency. We don't actually want to do that. You don't need to set transparency at all times. Transparency is by default it is 1. So get component transform, and technically we don't even need to write this. We can, if you want. You can set it to 0 or you can set it somewhere else, but you can just put it at 0. You don't have to put it anywhere else. This is like the bare minimum that you need, because you'll see that transform position defaults to 0, 0, 0. But for this example, we're actually going to do something cool. So get component. I'm sorry I'm making you guys delete things and then rewrite them and then delete them and then rewrite them. There's only one reason. I'm not actually making you write the regular thing. I'm only making you change the position Z. So what we're going to do is set it to -1. So I don't know if you guys know like Z layering. All this is like ordering. We are putting the hello world like sign below link. So that link, because link is at 0, renders on top of it. So now if we run it, you can now see hello world. And now you can see the camera moving. So when I go over here, go down here, and up here, you'll notice its link is also still like 10% transparent, so you can actually see hello world through his face. It's funny. But yeah, you'll notice this all starts, everything starts to move. This camera is a moving camera, and this is a world. So we can place a whole bunch of different rooms around here, basically just different sprites, and make rooms, quote unquote, and you can explore them using whatever sprite you make. Yeah, that is all for this tutorial. Your only task for today that I'm expecting is create a new entity. That's it. Make sure to write that. Make sure to create a new entity. Make sure to test things out, and you know, just mess around. Just have fun. Try to like this is your first like game in the framework. You can move around. You can do things. This is just have fun with it. Like do some cool things. Have fun. Next week's video will include animations and things like that, and a player controller. So you'll be able to like attack and run around. Attacking won't actually attack anything, but it'll run the attack animation. Because we won't have physics in during that. But yeah, that will be later for like actual attacking. That'll be later. Hopefully this is a good foundation for you guys to get started with your assignment that is due in October. It's due in 2 weeks, I believe. This way you guys can get started and place everything. And then we will be catching up with physics and animations within the next week. And that is all. If you have any questions about anything in this video that you saw, please do not forget to add, leave a reply in the discussion board with a timestamp and your question. I'll be checking those periodically, as well as I will be checking them during our tutorial slot. And I will be going over any questions that I see in there. So leave any questions that you want answered at the tutorial in that discussion board. Because then that tutorial will be recorded, and so there will be a Q&A video with every single answer to every single a Q&A video, quote unquote. It'll just be a recorded tutorial session with every single answer to every single question that you guys had in the discussion board. Along with asking questions in there, please make sure to post like a picture of your new entity. Like, for example, I'll include a picture of Link with Hello World in the background. I may include a GIF. You can include a GIF if you want of Link moving around with another entity, and another entity just in there. But we have just passed an hour, just a little bit over. And I hope you guys enjoy. I'll do my best to keep the tutorial on Wednesday to below time, to make sure that this is fair and that we're not taking up too much of anyone's time per week. thank you. And I hope everyone has an amazing day. And I look forward to seeing you all on Wednesday. Bye.